Okay, here we're working on the Chapter 2 review questions for your midterm exam. So let's get to it. So this is the key. All right, so when we make a truth value table, what we want to do is we want to have all the combinations of true and false. So one way we could do that is to put in the one column true, true, false, false, and the other column to alternate true, false, true, false. However you do it, you should have true, true, false, 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 true, true, false, all the different combinations. Now if we have this column for not P, it's going to be the opposite of the P column, so we can ignore Q and just do the opposite of the P column. This is not P or Q, so it's going to be not P or Q. So if it's true or false, it's always going to be true. If it's false or false, it's going to be false. If it's true or true, it'll be true. And if it's false or true, it'll be true. This is not P or Q, just as this. So for this last column, it looks like it's a lot, but really it's just P and this column. So it's true and true, which is true. It's true and false, which is false. It's false and true, which is false. And it's false and true, which is false. And we're done. For this space, we want to make we want to actually make a truth value table for not P or not Q. So first off, we want to start with P. We want to start with Q. We're going to need a not P. We're going to need not Q. And then, of course, we're going to need the final not P or not Q. When you make your truth value table, you should have the last column as what's given. So here it's given not P or not Q. So that's what we're going to make our last column. So let's make a nice little table here. Doesn't need to be perfect, but we do want to have enough rows for our different combinations. So again, P and Q, we should have all the combinations. So true, true, false, false, true, false, true, false. Not P is going to be the opposite of the P column. So if we have true, true, false, false, we're going to have false, false, true, true. Not Q, it's going to be the opposite of the Q's. So false, true, false, true. And finally, not P or not Q, we're going to look at just these last two columns and ignore the rest. So if it's false or false, it'll be false. If it's false or true, it'll be true. If it's true or false, it'll be true. And if it's true or true, it'll be true. Notice for or statements, for disjunctions, true overrides, whereas for and statements, conjunctions, false overrides. Okay, here I'm actually going to use the typewriter. So converse statement is, well, here, we'll do this. I'll write this out first. So a conditional statement is always going to be if P, then Q. The converse is going to be if Q, then P. The inverse will be if not P, then not Q. And the contrapositive will be if not Q, then not P. So if we look at this, we can say, all right, well, two angles being supplementary, that's going to be P, and they form a linear pair, that's going to be Q. So if we have, the converse is if Q, then P, if two angles form a linear pair, then they are supplementary. We'll worry about the truth value in just a second. And so the inverse is going to be not statements. So if not P, so if two angles are not supplementary, then they do not form a linear pair. You don't need to capitalize the not. I'm just doing that to really emphasize the point that these are not statements. And finally, the contrapositive, if not Q, so if two angles do not form a linear pair, then they are not supplementary. So try and map that out. Look at some other examples too. Okay, so if we look at the truth value, so if two angles are supplementary, then they form a linear pair. Is that true? No, it's not true at all. A lot of supplementary angles are linear pair, yeah, but just because we can have two supplementary angles that add up to 180, and they don't have to be next to each other to form a linear pair. So this is actually false. The converse, though, if two angles form a linear pair, then they are supplementary. Yeah, that's true. That's the true statement. If two angles are not supplementary, then they do not form a linear pair. Again, we can have two angles. Yeah, so if the angles are not supplementary, there's no way that they can be a linear pair. So that's going to be true. And if two angles do not form a linear pair, then they are not supplementary. No, that's not true. We can have two angles that are supplementary but not a linear pair. So this is false. So you have to think a little bit about this logically. I know logic is not everybody's favorite, and it's very difficult. It just comes with time. So take your time. The exam is designed so that you have time to reason this out and think about it. So use that time appropriately and really put your mind to it. Here we want to write the words for these. So the P statement is supplementary angles sum to 180 degrees, and adjacent angles share a common side. So if we have P and not Q, this is going to be supplementary angles measures sum to 180 degrees. There we go. Oops. And again, we're going to have that and statement. So and adjacent angles, it's a not Q, so do not share a common side. Again, we'll evaluate the truth value for this in just a second. And for the next one, it's a not P, so supplementary angles measures do not sum to 180 degrees. Or adjacent angles share a common side. Okay, so let me fix this grammar and then we will get right to it. So for the truth values, so here, supplementary angles measures sum to 180 degrees. Well, that's true, so I can make a little note, that's true. Then we have an and. Adjacent angles do not share a common side. Well, that's false. So if we have something that's true and false, the truth value is going to be false. Some people are still writing invalid and valid. Whenever we have a truth value, it's going to be true or false. So know the difference. We have supplementary angles measures do not sum to 180. That is false. And we have an or statement. Adjacent angles share a common side. That's true. So if we have false or true, that is, of course, going to be true. Okay. So here we have if two angles form a linear pair, then they're supplementary. If two angles are supplementary, then their angles form a linear pair. This is basically a question about the law of syllogism. So look at this. If two angles form a linear pair, right, then they are supplementary. Here it says if two angles are supplementary, so it's the same statement, then their measures add up to 180. So this is the whole if P then Q, and if Q then R. So so what we can conclude from that is if P then R. So what we would write is if two angles form a linear pair, then their measures add up to 180. And the law that applies there is the law of syllogism. It's just like the transitive property. Okay, in here we have a plane can be drawn through any 2 points. On a plane there exists points A and B. A line can be drawn through points A and B. So here we can sort of see a little step by step. So we know that a line can be drawn through any 2 points. So that's P. This is on a plane there exists points A and B. Okay, so Q. Now a line can be drawn through points A and B. So that's not a great example, but that's if P then Q. So if we know that P is true and Q is true, then if P then Q is true. Yeah, so that's going to be true. Oh, is it a valid conclusion? Yes. And this is the law of detachment. So again, if we know that P is true and Q is true, then if P then Q must be true. That's law of detachment. And I think this is it. Yeah, this is it. Okay, so here, complete the proof. Actually, there's a typo here. This really should be not -2. This should be -4. Because the first step is always the given. So we get 6x plus 5 equals 4x minus 3. And that is given. Here we have 6x equals 4x minus 8. What happened was the 5 went away. So that is the subtraction property. Next up, we can say we're using the subtraction property again. So we're going to have 2x equals -8. We subtracted the 4x from both sides. And finally, we divide by +2 to get x equals -4. And this is the division property. And that's it. That's all we needed. And finally, we have another proof here. So what we want to do is we want to say our given statements first. So AB is perpendicular to BC, and angle 2 and angle 3 are complementary. And this is the given. So for the second step here, okay, so we know that 2 and 3 are complementary. But if we look, AB and BC are perpendicular. So that means, by definition, angles 1 and angles 2 are complementary. And this is because we can just say definition of perpendicular lines. Perpendicular lines meet at a right angle, so angles 1 and 2 must be complementary. For step 3, well, if we know that 1 and 2 are complementary and 2 and 3 are complementary, we can say that angle 1 is congruent to angle 3, and this is actually the complement angle theorem. So remember, this was a specific theorem we looked at where we said, well, if angles 1 and angles 3 are complementary to the same angle, here angle 2, angles 1 and angles 3 must be the same measure. So that's it. So keep studying, keep looking through your proofs, and keep up the good work.